Hi everyone, my name's Amy Boyd. I'm a cloud advocate at Microsoft, specialising in AI and machine learning. And in this session, I want to talk to you a little bit about taking your machine learning models to the next level using a great end-to-end cloud service called Azure Machine Learning. If you've not used Azure Machine Learning before and you're currently in the process of building machine learning models or projects inside your business, I really hope this session will be incredibly useful for you. So first things first, I always like to start with some resources. So it sounds odd, I always put them at the start and the end. If you go and take a look at these links, you'll get an idea of the things we're going to try and cover during this session. So I highly recommend going to check out the Microsoft learning path that is all centered around building machine learning models using Azure Machine Learning. So if you go to aka.ms/dp100-AML, you'll find a whole learning path and that'll go into a lot of detail. So I highly recommend watch this session, go there, go and get hands-on yourself and learn even more about this platform. We're going to go through a specific scenario that relates to a fictitious retail company. We're going to see how they might look at applying natural language processing specifically. And if you want to get a hold of the code, take a look at it a little bit deeper, you actually can do. So you can go to aka.ms/AIML40 repo. That'll take you to GitHub where you can get access to all the information you need about this session. And then finally, if you go to aka.ms/9tipsProdML, you'll actually get some further reading from an amazing member of our team called Ari. Ari is an absolute expert in this space, and he's done a really great blog post there thinking about some of the stuff that really matters when you're taking your machine learning models to production. So first off, let's recap just some basic machine learning applications. Now, machine learning covers so many different areas, right? It's not a sort of one thing applied in a similar scenario. There are so many different approaches to so many different types of machine learning application. So whether we're thinking about recommendations in e-commerce systems, the great advances we've made in computer vision, or even the amazing sort of production workloads we're starting to see with predictive maintenance and logistics pipelines. So really anything in businesses and manufacturing around efficiency. But then you can also look at things that are maybe still considered a little bit more cutting edge. So something like autonomous agents, thinking of autonomous vehicles, is probably the one that comes to mind the most, but also thinking about a lot of applications that relate to reinforcement learning, so a specific type of machine learning that still is airing into sort of mainstream, but still very much in research. But in this session, we're going to focus on one area specific, and that is language understanding or natural language processing that it's known for in the machine learning space. Now, it's not just about analysing text, which we are going to do. It's also thinking about how you can apply it to your business. So whether you actually pair it with ambient computing and you're actually able to analyse data and text and interactions and speech inside a mixed reality world, whether it's all about automation and scaling. So rather than having people look at reams and reams of text and understand it, actually providing some support for those people to really summarize and understand the data that is coming their way, and so they can be incredibly efficient about how they approach their job. And then finally, a really interesting area actually is unlocking unstructured data. So data in the past that we didn't think we could truly understand and act on automatically. You're now able to start doing that by extracting text, data, images, etc. from documents. And it's a really, really valuable part of language understanding. So in this session, as I mentioned, we're going to apply this to a business scenario. So please meet Tailwind Traders. Tailwind Traders are a fictitious retail company. They are experts in the DIY space, but we are actually looking at how they can progress further into the retail space. So what does that look like when they're starting to want to understand a lot more about the products that people are buying, their amazing online presence using their website and their native application, and actually start analysing the feedback from customers and where they should start investing further, or where they should be making maybe more improvements as well. And so if Tailwind traders are wanting to start, taking some of the their retail and their DIY product information and reviews, they actually want to take these and start analysing them. Now, where do they start, right? I mean, there are so many technologies out there, and so something about this session that I hope you take away is kind of maybe how to get started in this space, where to start the information overload, I guess, or the approach that you're going to take to applying natural language processing. And so first things first is Tailwind traders are going to look at pre-built AI first off. So they are going to test it very, very quickly. They're going to use the Azure Cognitive Services Text Analytics API. A lot of people are familiar with the cognitive services, but these are pre-built APIs that you send off a piece of text and you get a lot of information back. So these cognitive services are a really great start. They're very easy to test. They're just API calls. So you can use pretty much any language as long as you can use a REST API, any platform. And there's a great community that backs them over on GitHub, Stack Overflow, MSDN, etc. And I highly recommend the documentation personally. There's some awesome samples that mean that you can get started really, really quickly. And so in this case, Tailwind traders are finding it incredibly useful to actually quickly test a few of their reviews, different types of reviews maybe send, a set of 100 through an Azure Cognitive Services API, get some information back and understand if it's bespoke enough for what they're looking for. So the Azure Cognitive Services are brilliant, but they are built on what we have trained them on as Microsoft. And so because they're pre-built, you don't need to worry about managing them or anything. But you also can't necessarily make them incredibly bespoke for your very specific use cases. And so first off, Tailwind traders want to go and double check whether this works for them. So one of the really nice pieces is these are so simple to interact with. So you can put in a simple sentence. So in this case, the food was very flavoursome. The service was very, very attentive. Would go back to this restaurant if visiting London again. And so what you'll notice is if we just send that piece of text via REST API, the type of information we can get back is what language it's in, any key phrases, so service, food, restaurant, and London. These are all things that we could group on, that we could filter on, that we can make word clouds from. Think about kind of that data science approach of it's actually not just what this API brings back, it's then the next step as to what you do with that information that is the most important personally. You can get back sentiment, so 80% and green, showing that this is a very positive sentiment. As well as named entities and anything that kind of links, so actually being able to link off to the word London. Okay, so I want to step out of our Tailwind trader scenario very, very quickly and talk to you about the 80-20 rule. If you've ever heard of the 80-20 rule, you'll know exactly what I mean, and you'll probably be pulling this face. Because the 80-20 rule is so true. So a lot of time in machine learning will now say that 80% of the time, pre-built AI services can really help you to solve your solution. But 20% of the time, you need to then start looking into more custom scenarios, so more bespoke machine learning algorithms. And that's okay. But obviously, with both sides of this equation come trade-offs. So pre-built AI, easy to manage, easy to integrate, constantly improving. Brilliant. And all you have to do is call a REST API and implement it into your application. Very nice. Downsides, it's not always as bespoke as you're looking for. It might not actually provide you the deep level of detail that you want to try and train yourself. 20% side, positives, you can really get into those custom items. You can train it on your specific experience, specific data. You can choose the algorithms. You can experiment with the setup, and you can also send it into production and manage it. Now, managing it could also land under a disadvantage because managing machine learning models is like any other architecture. It's not trivial. Being able to retrain these models, keep data sets up to date, how a team's working together to make sure we're improving these models over time. And also, where do we start with the huge range of different things that we can do with machine learning? So I just wanted to revisit the 80-20 rule that Tailwind Traders have also landed themselves with here. Okay, so back into our Tailwind Traders scenario, we are going to be moving now from cognitive services to Azure Machine Learning. The Tailwind Traders team evaluated the pre-built AI, and one of the things that they really wanted to do was do a little bit more bespoke on the specific things in maybe a larger review that are actually picked out for their own specific sentiment. And also maybe things like product names within inside their options were not being picked up. And so what they're going to try and do is they're going to take a look at what custom machine learning would look like if they were to start to build their own product. And so something they're looking into, they're starting to use is Azure Machine Learning. So what is Azure Machine Learning? Azure Machine Learning is a set of Azure cloud services. So it's an environment that your team of data scientists or people who are getting into the machine learning space can go into, work as a group, and actually build out machine learning models from end to end. There's some great services in there, but there's also the ability to think about data sets management, compute resources to leverage, notebooks and sort of code experiences, as well as pre-built no-code, low-code services as well. And then finally thinking about that management section. So how do we build pipelines that allow us to manage our deployments and pipelines that allow us to build a life cycle for our machine learning model. This set of Azure cloud services are also combined with a Python SDK, and that allows us to interact using code. And some of the things that we'll show you is actually how easy it is to embed maybe models that you've already built using Python and actually use the Azure Machine Learning service to help you experiment, build, and send to production. One of the things I wanted to deep dive into first with the Azure Machine Learning service is some of the services that we also provide in that space. I have another session on Saturday at SQL Bits that talks a little bit about the Azure Machine Learning Designer, so the low-code, no-code experience for building out machine learning models. But in this session, I just want to very briefly touch on something called automated machine learning. So firstly, what is automated machine learning? A lot of people see it as building a baseline model that allows you to understand very quickly what your data looks like, what your goals are, any constraints that you have, and then automated machine learning will take your data and your asks and it will actually run over lots and lots of different types of models until you have that optimized model out of the service. So some of your models might not be as positive, some of them might be really good, and then one thing that you can do is really hone in on those great models, those really good approaches for the problem that you're trying to solve, and then potentially amplify that from there into even more custom or bespoke machine learning. So what I want to do now is show you how we can move from text analytics to automated machine learning using the Azure Machine Learning service and actually apply it to our text scenario, which is our reviews for products. Okay, so here we are in the Azure portal, and I have a machine learning service instance created called Ignite the Tour. It's in West Europe. So basically, if you want to create a machine learning instance, you just go to create a new resource, type in machine learning, look for this logo, and all you have to give it really is a lot of basic information. Just one thing to mention, the workspace edition. I chose the enterprise one because I'm going to be using automated machine learning as a service in the UI. And I'm also going to be using the Azure Machine Learning Designer for another session that I'm running at SQL Bits. So If you were just doing the code piece, which we'll look at shortly, you can actually just have the basic subscription. So do go and take a look at the pricing around these two different things. But one thing you'll notice about this portal in the Azure portal is there's a lot to do around access control and management of the service, but the place that I spend the most time is actually in the Azure Machine Learning Studio, which is like where I create most of my experiments, the code, and spend most of my time. So if you click on Launch Now, it actually opens the Azure Machine Learning Studio. And then from there, we can see all the different services that are available to us, things that I've already been running, compute that I have available to me, as well as my account, and I can change subscriptions, etc. So in this demo, I want to show you a little bit about how we can create a baseline model, how we can understand what type of things our model might be quite good at, and what algorithms we might want to use. And so I'm in the home page right now. The first place I'm going to go quickly is the data sets under assets. And under my registers data sets, what we're going to be able to see, if I scroll down a little bit, is this AutoML clothing data set. So this is where it is in my blob storage. This is some basic details. One of my favorite parts, a little bit of code so you can access it very, very quickly and easily. But the explore module is really, really useful. And basically what this is going to do, it's just going to show me a few of the top rows and tell us a little bit more about what's going on. So we only have 2 columns, but we have around 10,000 rows available to us. Each one of these columns, we've got some review text about our retail stores and our reviews. And then we've got the 1 to 5 rating, 5 being amazing and 1 being not so great. And so one of the things we might want to do is actually then apply this data set as it is, basic text, and do a classification problem on the rating. And so a really, really great approach is to use automated machine learning. This comes under the author section. So if you click on that, you can see ones that I have previously run here, and we can dive into one of them in a moment. But if I create a new automated ML run, I can select the data set that I want to use. You can actually click on it as well here. And it can give you a data preview just so that you know you're about to run the right thing, because obviously automated machine learning experiments are quite lengthy in process. They take quite a while to run because obviously it's trying lots and lots of different algorithms. And so you can double check that you're using the right thing, and you can also choose data statistics. Okay, so once we've looked at our data set, we can then go to next. And in this next bit, we're going to actually configure the run, so the experiment. We're going to define what we want to do. So I'm going to select an existing experiment that I've created, which is our AIML 40 AutoML. So this is related to the project that I'm working on, and this is the approach that I'm using. Under target column, this is what you want the model to be trained to predict. So in our case, that's the rating. So we want it to use the review text to actually do the rating. And then we're under select compute cluster. This is actually going to be where the AutoML starts training all those different experiments. And so I have some compute clusters available to me. I could select a GPU cluster if I wanted to, but given this data set isn't that big, I'm going to choose a CPU cluster. These compute clusters are incredible. They're part of this scalable compute. So I have about 4 nodes of CPU machines that I can submit my experiment to, and it will deal with the concurrency between them, and it will go run them, and then once it's finished, it will actually bring them all back down to 0, and I only truly pay for what I'm actually using compute-wise. This is the best thing ever. It's one of my favourite things about it. Okay, so now we're going to select the type of machine learning task. So ours is actually a classification task. Sometimes deep learning will help, and in our case it will with text data. So we're going to select the enable deep learning options as well. The other options available to you are regression, so how much or how many, and also time series forecasting, which is amazing, so predict values based on time. So we've selected our task. There's also some great additional configuration settings. So you can be as specific or as unspecific as you want to be. You can change the metric, for example, to something, we'll keep it as accuracy. You can explain the best model, which is a lot about explainability and understanding truly what machine learning model has actually been built, and hopefully that it doesn't skew too much towards something in particular. If you know that a certain algorithm is not going to work for your data, you can actually say, okay, don't put these into the option. For example, you might be like, don't use SVMs. We want you to, look at other things. Actually, SVMs might be quite good for text, so we might want to not do that. And then we've also got exit criterion. So this says 24 hours. This is a trade-off, right? This is saying how long do you want to be paying for this to run compared to the results that you will get out. So you could either do the time, so that's what we're going to do, we're just going to put it to 1 hour, or you could set actually a metric threshold. This is pretty clever. You can set a metric threshold between 0 and 1. So you could actually say, oh, actually, if it goes above 0.9, I'm happy with that as an accuracy. You can then finish, we'll evaluate from there. But, it technically, it could find another algorithm that actually had a higher accuracy. So it's always worth keeping that in mind. Validation, train validation, you can tell how much percentage of the data you want to use for validation. And then also concurrency, so how many different runs will it run all at once. And I tend to keep them as default. You can also look at the data. So if you have lots of columns of data here, for example, you might actually not want them all to be used. Obviously, we know, again, a trade-off of machine learning. The more data you submit, the longer it takes to run, and also can really cloud the judgment and its generalization of a model. So you might want to actually, if you had lots and lots of different algorithms, features, you might want to turn off some of these if they were duplicates or something like that. I've also enabled featureization, so I've said go ahead, do pre-processing on this data to make sure that it's in the most optimized format. If you want to find out more about what it does for featureization specifically, you can go and take a look at the link here. And then I'll click finish, and what this is going to do, it's going to go off, create my automated machine learning run, and it's going to start running my data with my task against lots of different algorithms and parameter setups. And then what we'll do is we'll go and look at one that we created previously. So we can see it will just get started in a minute. It's got its run ID and its run number, so worth keeping these in mind, but you can always look them up, as well as some of the settings that we did for it. So we can always come back to this one. Let's go and have a look at a different one. So in our runs here, we can see, here's one I ran earlier. So this one is completed. It took about 44 minutes to run through, and it actually decided the best model was a max abs scalar with stochastic gradient descent as the loss function. And then you also can see actually the accuracy was 0.97. You can view all of the metrics associated because accuracy might be great, but for example, if precision, so there's precision 93 to 97, score weighted, that's the one we want. And recall is also very similar at 97, so F1 score is going to be pretty similar, and that's actually a really good outcome because accuracy can be a really skewed metric, so always good to double check all of them. And then one thing that we can do, we can go under data guardrails, and this tells us a bit more about the featureization that it did. So it actually shows us that there's a bit of an imbalance in our classes. So specifically our class of ones of reviews is actually very small compared to the whole data set. We might want to revisit that because that might improve our data, or actually the ability for it to predict the class 1. It didn't have any missing feature values. It didn't detect any high cardinality features, so that's great. But this is where you can really see what it did for its featureization. But the most impressive bit is actually being able to look at all the different models that it ran. And so when you see them like this and they're all kind of listing the same thing, it's that the parameters that are being set or the sampling that is being used is quite different. So we all know that when we run machine learning experiments, we'll run them and then we'll tweak very, very slightly lots of different things. And so it's exactly what it's doing here. Automated machine learning is a really interesting new sort of approach that people are using, and it's incredibly useful. And so we can see it tried lots of different models. Some of them will fail, some of them won't support, but that's fine because it's going to go through many, many different ones, and then they will get ranked by their accuracy. For the best one, you can actually view an explanation. That's a whole another piece. If you go and look in the documentation around Azure Machine Learning explainability, you'll see some of the work that we're doing in that space. You can also click on the algorithm name specifically, and if you are ready and you're happy, you can actually go straight away from here and actually deploy this if you wanted to, or go into the specific metrics of this model and select whatever you need, take a look at the graphs, etc. You can really go ahead and have a look at what is going on. So that is automated machine learning. We used it to try and understand what our baseline of predicting review sentiment would be. And we can see it did a pretty decent job. Okay, so Tailwind Traders have looked at the Azure Cognitive Services for text processing and sentiment analysis. We then went ahead and applied automated machine learning in order to be able to get a good baseline model and understand the predictability of building a custom model on our data set. And then now the Tailwind Traders team have done some research and they've found an interesting open source framework model that they actually want to use in their own custom machine learning model. So this approach is called the NLP Architect Aspect-Based Sentiment Analysis. What does this mean? Aspect-based sentiment analysis is basically the ability to assign sentiment to specific aspects, so to specific items. So if you have a review with many, many sentences in it, you can actually break this apart and also understand the specific sentiment depending on the object itself. So was the price the problem? Was the food really good? Was it meat? Was it drinks, etc.? If it was, for example, for a restaurant data set. So Tailwind Traders are going to go and try and apply this framework. Now, in the past, data scientists would tend to work in solitary situations and build out, code that could then be run. They'll use things like Python notebooks, Jupyter notebooks, for example, and they would build out the code. Now, we're in a situation where we now need to understand truly what it's like to manage a machine learning environment. Because we're going to take this to production, we don't want to start in that kind of like proof of concept mindset where we can just throw different things together. We kind of want to be thinking, are we using the tooling that's going to help us think about managing our machine learning models? And so some of the challenges that Tailwind Traders might need to think about are things like environmental dependencies. So when an open source package changes, how are we relying on that dependency? As well as, how does the actual environment set up so that if I'm working on it and also Steve is working on it, when we're working on it together, we're making sure that we're working with the same development environment and we're not missing different packages to run that code. I touched on it there, but say if me and Steve are working together, we actually want to be able to cross-collaborate. So the ability for me to be able to review different experiments that Steve has run, or actually have access to the same repository and notebooks within inside the virtual machine instances is incredibly important. Data and compute management, because machine learning by nature is heavy for data and compute. Actually being able to manage that within inside an organization, because compute and data set storage in the cloud obviously relates to some form of cost. So understanding how can we manage and understand what compute I can use as someone as part of this project is important. The ability to be able to apply compliance, so having access control, we know who's edited the code, we know who deployed it, etc. But also interpretability, so taking that step further into AI machine learning and truly understanding what our models are doing and why they're doing it, and if any data is skewing it, and if so, what are we going to do about that? And then finally, distributed training. I mentioned the amazing scalable compute. Distributed training is fascinating. The ability for something to be able to put one problem across many different nodes, manage the working of that, and then also push all of that back to you is incredibly important. So there's a lot of challenges, right, for someone to set up an environment. And that's where the Azure Machine Learning end-to-end process and the service itself can actually help us, from preparing our data to using Jupyter, our favorite IDEs, to training and testing the model, as well as moving it into that kind of production environment, but the whole time orchestrating, maintaining, interpreting all of this. So I wanted to very quickly talk to you about how Azure Machine Learning works when you submit your own bespoke code. So I've got a little visual here. So from my computer, the first thing that happens is I'm actually creating, say, a Jupyter notebook, for example, and I'm writing code that is going to create an experiment. It's going to submit an experiment using the SDK. And so what happens when I run the run command, so to run an experiment and use all of the Azure Machine Learning service, what happens is a snapshot of that folder is actually sent to the service and is used for the experiment. So the files that I've been working on, the packages that it relates to, anything it needs to actually run that experiment. What that then does is create a Docker image. So parts of your code will talk about the exact setup and environment that you need in order to be able to run an experiment. And then that Docker image is actually deployed onto the compute target along with the snapshot. So your data and files from an image that is then deployed onto the compute target. And remember, the compute target deals with distributed computing all by itself. It then also, if you're using a data store rather than calling off to an API for data or pulling it from somewhere else, you can actually have the data store in Azure Machine Learning and mount it onto the compute target. Why is that so impressive? Actually mounting it onto the compute target, this idea of bringing the data as close to the compute and the processing as possible, is incredibly important. This saves a lot of efficiencies. And again, it will do all of this mounting for you as long as you tell it where the data store is. It will actually launch your script, so your specific train.py file that you're going to run, that will allow you to run all of your bespoke framework codes. So for example, the NLP architect framework, or if you're using Keras, or if you're using TensorFlow, etc. Whatever you normally use for bespoke machine learning, you can absolutely use in this process as well. It will then stream logs back out to the experiment, which can then actually be streamed back down to your device. So wherever you are, you can get constant updates of actually what is happening and how your experiment is running. So if you've run something locally like this before, maybe a Keras experiment using deep, neural networks, for example, you'll know that you can see when it's running through the data, and you can see where it's got to in the iterations and stuff like that. There's no reason that you shouldn't be able to do that here. So it's not just about sending this data off and then it kind of disappears off into the ether and you don't know what's happening. You always have those metrics and output logs streaming back to your device, and you can actually use the log functionality to make sure that anything you do want to see is available in those logs. And then finally, once it's finished, it copies over all of the outputs back to the experiment in the service, that you can then access all of the metrics and the outputs on your computer afterwards. So let's take it to our next demo, where we're going to use advanced machine learning frameworks such as NLP Architect in the Azure Machine Learning workspace. Okay, so we are back in the Azure Machine Learning Studio, and what we're going to do now is we can see our automated machine learning experiment is still running that we just created before. However, this time we're going to approach it slightly differently, and what I'm going to use is the notebooks or a Jupyter interface to actually write some bespoke Python code. If I go to the Compute tab, we can see I have compute instances. compute clusters, and inference in clusters. So this is kind of Kubernetes deployment. This is our scalable compute. So we can see that it's currently being used by our automated machine learning process. But under compute instances, you can actually create a virtual machine that is kind of like a developer standard size. So my AMB virtual environment. It's currently running. If we press stop, it does not cost us anything. So make sure you stop this when you're not running it. But one of the really nice things about creating one of these instead of just, another virtual machine in Azure is it already has great data science tools pre-installed, including things like RStudio. So I can actually open Jupyter from here and click on it, and it will open Jupyter in my AzureML instance in West Europe, for example. So we can see that it is a virtual machine within the environment, but it's absolutely available to use. And from there, if you've ever used Jupyter before, Jupyter is a very popular notebooks experience, and I'm going to use some Python code to actually use Jupyter because the notebook experience is actually really easy to build quickly and understand and explore your data. So I've got some different folders going on here, such as my notebooks folder, and we can see this notebook's in green. That's because I have it open. So if I open my ABSA notebook, so ABSA stands for Aspect-Based Sentiment Analysis. What we're going to do is we're going to use the NLP Architect framework to do aspect-based sentiment analysis using bespoke Python code. So first things first, we're going to bring in some basic import OS, some basic Python packages. We're going to bring in all the Azure Machine Learning packages we're going to need. And then we're also going to import things like Spacey, which is a popular visualization package, and our NLP architect, so our sort of open source framework. And we're going to see how we can actually run that. So if I run that, we'll also be able to check what the AzureML SDK version is. So you can see I'm currently using the 1.9.0 version. I'm going to set up a few variables. So we know that data and compute are incredibly important. So I'm going to set my cluster name to my GPU compute instance. I'm going to set my experiment name to aspect-based sentiment analysis. I'm also going to call my model that, and any deployments I'm going to do, I'm going to call that ABSA- and then this is Azure Container Instances. So just setting up a few Python variables we're going to need. Then we're going to start from step one. So we're going to set up our environment, and we're going to initialize our workspace from our configuration. So if I run this, it will connect to the workspace that I'm using just here. And if it didn't, sometimes it will prompt you to sign in, but it's obviously happy that I'm signed in here. Next, we're going to say, okay, we've got our compute cluster, our GPU compute, our scalable compute ready. So we're actually now going to say attach our experiment to our compute cluster. So we're going to get the compute target from our workspace with a certain name. So our cluster name above was set to GPU compute. Or if that's not there, we can actually create it. And we could set this to a GPU machine VM size. So if you used Azure before, you'll know you can go and look up all the different types. I also highly recommend choosing low priority because of the fraction of the cost if you're not in a hurry for these processes to finish. And then you can also set a minimum and a maximum nodes. If you set the minimum nodes to 0, it will not cost anything when it's not running. And when it scales up, that's what you'll pay for. So the maximum here is 4. You can obviously put that up to whatever is available within your subscription. And then what it will do is it will create this as a compute target in the Azure Machine Learning SDK, and it will tell us whether it has selected it or not. So it says, yeah, no worries, I'm going to use your GPU compute cluster. We're also going to get our default data store, which is an Azure Blob storage, and it's going to store that in the DS variable so that we can use it. So now we've got our workspace, our compute, and our data all sorted. So let's focus on the experiment. We can actually create an experiment if it doesn't already exist. So we said our experiment name was going to be ABSA. So we've put in that variable there, and we can say experiment, give it the workspace, and give it a name. That is now stored in this exp variable. And now we're going to look at creating an estimator. Now an estimator is basically what's telling this SDK code what it's actually going to run. So you can tell it, you can give it parameters if you wish. We're going to call this estimator our natural language processing one because we're doing NLP. We can tell it where it needs to go and find our scripts. So interestingly, you might be thinking, well, where is the actual NLP architect code? So if I go into here and I go back and we look in the scripts folder, what we can see is we've got a train.py and a score.py file. And so the train.py file, this is like any other Python code that you could run locally if you wish. But what we're able to do is we're able to kind of really push up the amount of data, because we wouldn't want to run, millions of lines of data on our own laptops anymore when we can actually leverage the power of the compute. And also, how do we, keep track of the outcomes of this? If I change some of these threshold values, etc., how do I know that these different things are going to be measured and that our whole team can work on them? So the SDK, in some senses, puts a wrapper around your code that allows you to build end-to-end, fully traceable, fully interpretable code for your machine learning group projects. So we can see using NLP Architect, you bring in your Python packages, you load the NLP Architect sentiment frameworks. We're going to say we can give it a few arguments so that when we train it, we can actually pass it different values if we wanted to. We can also download some of the dependencies that our aspects-based sentiment analysis has, so some of the spacey items and embeddings. We can double check that that's all ready for us with the different paths. So where are these different files? Now these are in our data folder in our Azure Blob storage under a clothing data. Now if you want to know where they are, if you go to here and you go into storage, go into containers, and the blob store, what you'll notice is we have this clothing data and we have lots of different files available to us in here. So we have some embeddings that it's going to use. We also have a small data set versus a much, much larger data set, and also a validation data set that we can use for testing. And so having it all in this space means we can easily call it within this code just by referencing it. We then use the train sentiment option with the aspects and the opinions. So an aspect is a sort of a noun or an item, and an opinion is a sentiment word. And then we can tell it how many iterations. So we give it the setup for it to train the model. We then create a new directory where we'll then put the outputs into our train and run directory, and what it will pass us back is two different files, an opinion lexicon and an aspect lexicon. We do a little bit of shuffling around to make sure these are in our outputs folder, and then we can do some items to make sure that we can actually reference this against a validation data set. So we can say, right, we know that in this validation data set where we expect the aspects and sentiments to be, and we can test whether it's doing what we expected, and etc. and etc. So it will run those validation predictions, and then it will do our Y predicted versus the trues, and then we can even bring in some scikit-learn metrics such as the F1 score. But one of the really nice bits of the SDK is run.log, where you can actually log any variable that you're running. So as we can see, we can say what is the length of the aspect lexicon, what is the length of the opinion lexicon, what is the F1 weighted score, for example. So you can see this is a sort of a very standard machine learning notebook experience, but this is going to be our train.py file that we actually call from this estimator. So it goes into the scripts file, it uses any parameters, it knows what compute target we want to use. We can provide it environmental variables. So one of the fun things about the NLP Architect library specifically is that it runs on CPU compute. It's actually optimized to run on CPU compute if we want it to. And then we can actually tell it where the entry script is. So our entry script is train.py when we submit this experiment. However, if you had a pre-processing piece that then called your train.py file, then it would do a chain in effect. So you just need to tell it where it needs to start. And then you can also add in any pip packages. So as you can see, the NLP architect is actually on GitHub. And you can tell exactly what versions of different pip packages you want as well. And so what this does is it creates the environment and all the assets that are needed to actually run your experiment. And then what we can do is we can finally submit this experiment. So under the run variable, we're going to say experiment.submit, and then we're going to pass it our estimator just here. So all the details it needs to actually run. And whilst it's running, I mentioned that it should pass all of the information back down to our actual notebook. So we don't send it off into the ether. We know exactly what's going on. And it actually provides us a really nice Jupyter widget where what we can see is currently queued status. It'll tell us the start time. It'll tell us how long it's been running and its run ID. Once it starts going, we'll get different files that we can monitor. And so if we have a look at one that we ran earlier, we can see this one completed. It provides me still my run ID. It didn't take us very long to run this one, but it did tell us all of those logged outputs that we did in the train.py file just down here, run.log. We can actually now see inside our Jupyter widget. Also, as I mentioned, if you've ever run these types of things before, you'll know that you tend to be able to see actually how it runs. So if we go into the driver logs, what you'll notice is it tells you, and if we scroll up, we can actually see it running through all the different sets of data multiple times, so for multiple iterations. And then actually telling you like what processing it's done and things like that. So you really are everything that you would get, say, in a terminal. If you ran this, you can see inside this widget. And so one thing that we can do is we can then have a look and test it against some sample data. So if we get a model that we already have, this ABSA 11 model, which is in our outputs folder now, we can get the actual output files. So if we take a look at them, we go into temp and outputs, we can take a look at the aspect lexicon. So what does it actually produce? Well, it takes all your sentences and then it puts this span class around anything that it considers an aspect. So everything, or runs, or let's keep scrolling a little bit, or something, what it looks like, for example. And what it will do is it will pick these out of the text based on some of the previous sort of built-in understanding that it has. And then finally, you can also have a look at the opinion lexicon. Now, this is a pre-populated lexicon, which it then trains on your data. So you can see that absence or absurdity is negative, whereas if we go down and say accomplish is positive. But if your data had a specific skew where actually accomplishing something was a real negative in your case, then you could actually have it so that when it's training, it actually changes this to negative. So it will start with a standard lexicon and then it will actually change these as it needs to. So that's what it outputs. And so we can load them in. We can provide it some simple stuff like loved the sweater but hated the pants. Really great outfit. I really like the shirts. That's all positive. Shoes are bad but perfect blouse. And then if we run that, so we would have seen this in the processing in the train script, and then actually run it and do some nice visualization, we can see that aspect-based sentiment analysis is truly happening here. So we can see the sweater, loved the sweater, so sweater is positive, hated the pants. Really great outfit. The outfit was great and the shirt was really positive. The blouse was positive, but the shoes were negative. And from here, we can start making some really interesting aggregated business decisions on what areas we might need to work on or what areas might be our strengths, for example. So in this session, what we did was we showed how you can use a bespoke advanced machine learning framework inside Azure Machine Learning and actually view a lot of the outputs in the Experiments tab. So you can actually compare them against each other as well. So we can see one of them is running right now, but we've got 5 highlighted. We can compare runs to each other depending on any of the outputs that we log. It really is an environment that you can truly work in as a team as you're progressing and experimenting with what's happening. So if you're interested in learning more and you're kind of, this looks interesting, but a 50-minute session is never going to be enough on something like this, I highly recommend going to Microsoft Learn and checking out the Azure Machine Learning learning path. So if you go to aka.ms/dp100-AML, you'll find an amazing learning path that will take you through step-by-step, hands-on, free, self-paced learning that you can take further straight after this session. You can find some of this code on GitHub at aka.ms/AIML40 repo. And if you're looking at taking machine learning projects to production, I highly recommend the article of further reading here by our teammate Ari at aka.ms/9 tips for production ML, so prod ML. Also, there are ways you can get certified in this area. So if you want to be a certified Azure data scientist, go to aka.ms/dp100-cert. The DP100 certification is the Azure Data Scientist certification, and a lot of what is covered is the Azure Machine Learning service. And so with that, I just want to say thanks so much for joining us, and I hope you have a great time at SQL Bits this year.